welcome everyone. Second session today, 6AW. We've got a role reversal now. Steve was chairman of the last one I was presenting, and now I'm chairman. And Steve, you're going to present to us on CICS self-service provisioning with IBM ZOS Cloud Broker. So without further ado, Steve, the room's yours.
Thanks, Rob.
Just mentioned at 11 o'clock, we'll be doing 1 minute silence for remembrance. So that'll be my job to interrupt then, just so everyone's aware.
Okay, yeah, title's a bit of a mouthful. I did try to come up with a more catchy title, but hopefully by the end of this session you'll know what IBM ZOS Cloud Broker is, which is the main objective of this session. So what I'll start with a brief introduction just to talk about cloud native development and self-service provisioning. We've been talking about on ZOS for a few years now, but what's making it a more pressing requirement is that other platforms are now doing it by default. So we need to ensure we have the same capabilities on the mainframe to keep ZOS relevant for new workloads. That will lead into an overview of what IBM ZOS Cloud Broker is and how it fits in to that scenario. I want to spend most of the time doing a demo from two perspectives, the systems programmer perspective and the cloud native developer perspective. And then we'll finish with a summary. So if you've got questions, if you just put them in the chat, and I'm sure Rob will flag them up as we go through this. So I'm going to start. If you were on Rob's session earlier, you will have heard them talk about IBM design thinking and personas. So let's meet Zach, the systems programmer. Not normally we talk about Stan, the CICS systems programmer. We go through this. I think Zach is a more generic system programmer, so he doesn't just do CICS, he does ZOS, IMS, DB2, he does everything. And he has control over all ZOS resources and the responsibility. And he's bombarded with requests from developers like Freya. We'll meet Freya in a second. But essentially, Zach prioritizes production. He needs to keep the show on the road, but he also needs to support his developers and give them the development environments and keep those environments up to date with what they need. 20, 30 years ago, he provisioned hundreds of development environments, and those environments soon became out of date, and he suspects half them aren't used anymore. In fact, he knows half them aren't used anymore. But a big part of his time, and much to his annoyance, is every year when he applies maintenance, he has to keep these environments updated and tested, even though he suspects they're not being used. So let's meet Freya. So Freya is there's no stereotypes here, obviously. So Freya is a cloud native developer. She doesn't use ISPF. She's never heard of ISPF. She probably doesn't use Eclipse either. She does all her best work in Starbucks, in fact. All she needs is her laptop, a good Wi-Fi connection, and she can connect to her cloud platform and do all her work there. However, when it comes to working when she needs to test her applications with ZOS, she relies heavily on Zach. Zach asks her complicated questions like, what CICS region are you using? Questions she can't answer. What transaction ID are you using? And it's quite a frustrating experience. And Zach is often too busy to answer her questions. And when he does ask her questions, she often doesn't know the answer. And it really puts her off developing applications for the mainframe. She can't work with the mainframe in the same way she works with our other platforms. So I don't know how familiar that scenario is to you. So let's look at an alternative, because Zach is not as clapped out and disillusioned as he looks. He's got some new tools, and he's been able to decommission all of those, or most of those development environments, and replace them with a set of templates. And those templates can be published in a cloud platform, and developers can use those templates to provision their own CICS regions. So Freya's delighted with this. This is what she's used to. She's used to containerized deployments, self-service deployments of databases, middleware, and now she can do the same thing for her ZOS applications. Zach, in the meantime, still maintains the control and visibility over those environments. He owns the templates. Those templates determine that the provisioned resources comply with site standards, and he can control the number of instances that are provisioned for each team. So the ZOS platform now looks a lot more attractive to developers, and therefore a lot more attractive to deploying new workloads. So it's partly frivolous, partly simplistic, but the key message there is it's becoming the norm now with cloud native development for developers to build and deploy their own applications without needing the assistance of administrators or systems programmers. And in order for the mainframe to remain attractive as a platform for new applications, the mainframe needs to play in that same ballpark. So let me introduce IBM ZOS Cloud Broker, and let's put it in some context. If any of you were on Mark Anzani's initial keynote last week, he was reminiscing over the last 38 years in IBM. And when he got to around about 2010, he was reminiscing about the start of the cloud journey for ZOS. And I must admit, at the time, I thought, was it really that long ago? But actually, yes. And so we do have quite a rich tool set in ZOS already to support self-service provisioning in a cloud-like manner. And some of you may have heard of cloud provisioning and management for ZOS, which is pictured here on the right-hand side of the file. That's an outcome of that initiative. So we do have a capability in ZOS to support self-service provisioning. But what is new is the ability to integrate that capability with cloud-native platforms such as Red Hat OpenShift, Pivotal Cloud Foundry. And that's done through ZOS Cloud Broker. And that capability with Cloud Broker and Cloud Provisioning Management working together means that the capabilities we have to provision CICS regions, DB2 databases, IMS databases, etc., is now available, or can be made available in the cloud application platforms. And so when we go through the demonstration, we will show the systems programmer signing on to the cloud provisioning management function, which is available with ZOS. It's a plugin which is available for ZOSMF. No extra license required. That's part of the ZOS license. Just make sure you're on the more recent version of ZOS you are on, the better. And the systems programmer will publish a template and then can log on to Cloud Broker and make that template available within the cloud platform. The cloud native developer then, using the native tools and processes they're used to, can then provision CICS and DB2 and IMS in the same way as they might provision a MariaDB database or Nginx web server, for example. And most importantly, as well as provision, they can deprovision those resources as well, because the bane of ZAC's life is the number of environments that don't get deprovisioned after developers are finished with them. And so the deprovisioning process is just as important as the provisioning process. So shortly we'll start the demo. But just to give you an overview of what we're going to go through, we'll start on the right-hand side. So the systems programmer will sign on to ZOSMF, and the cloud provisioning and management function of ZOSMF essentially provides three main resources which the systems programmer will configure. It provides something called a domain. Now the domain, think of a domain either as a sysplex itself, or an LPAR within the sysplex, or a subset of the resources within either the sysplex or the LPAR. Basically a logical grouping of resources which can be made available for provisioning middleware. Each domain has one or more tenants, and so think of tenants as project teams or development teams, and each tenant for each tenant, the systems programmer will make available templates that are applicable to that team. So for example, a template which provisions a CICS region, a template which provisions a database. We can also provision what's called composite templates. So where an application needs a CICS region and a database, we can provide composite templates. Or a composite template might be a CICS MRO environment, which might need a routing region, a couple of AORs, and a file owning region. Having published those things within ZOSMF, the systems programmer can then make those published templates available within the OpenShift platform via the cloud broker. And as we'll see in the demo, how that manifests itself is that the middleware resources on ZOS will appear as items within the developer catalog. Now, the developer catalog is central to the OpenShift container platform. That's typically a set of deployable, containerized resources, which developers are used to picking and choosing what they need to build and test their application. So when we get to the second part of the demo, to go through the self-service provisioning itself, what we'll see is the systems programmer's job is done. So the developer can sign on to the OpenShift container platform and start to deploy the resources needed to run and test their application. So in the example we'll go through, we're going to use the CICS catalog manager hub. That's the office supplies application which is provided with CICS, which you may have seen before. We have a web front end to the application, which is written in Node.js. It's actually, just to go off topic for a second, it's actually written to showcase the Node.js support in CICS, which came in with 5.5. But one aspect of that support for Node.js and CICS, Node.js web and CICS, is that it uses an API which makes the Node.js applications portable. So although the web app may be destined to run in CICS when it reaches production, from a development point of view, that web app can be deployed wherever is convenient for the developer, and that may be on their workstation. They can run a Node.js runtime on their workstation and test it there. But similarly, as we will show, we can take the same web app and deploy it into an OpenShift environment and dynamically configure and deploy the Node.js runtime there. So it's a good example of developing and building in a cloud-native manner. So having deployed the front-end web app, the developer will then need to deploy the resources in ZOS which are needed to test the web app, which essentially means the CICS application. Now, the catalog manager uses vSAM as its data store, and I'm going to slightly cheat here. Although I could deploy the vSAM data using cloud provisioning and management, just to shorten the demo, I've actually pre-provisioned the vSAM files for this demo. But as we go through it, I'll show you how it would be possible to deploy the vSAM data as well as part of the application. The developer will then deploy the CICS region itself, and this being a web app, it will need an HTTP port provisioned with the CICS region. Fortuitously, the template we provide, we'll get onto templates and how they're provided, includes the option to automatically, dynamically provision HTTP ports. So we can easily do that. And then the final piece, we need to deploy the catalog manager app itself into CICS, which is a set of COBOL programs, some CSD definitions, and a couple of JSON web services which will expose that application to the web app. So just one final thing before we go to the demo, because I'm not going to show this in the demo itself. The template we're using to provision CICS is provided by something called the IBM Zos Provisioning Toolkit. Some of you may have heard of this. It's been around a few years. And as well as CICS, it provides templates which can be used in cloud provisioning and management to provision CICS regions, a variety of different topologies for CICS regions, and ZOS Connect. And here on the left-hand side, we see part of the properties file, which helps determine the characteristics of the region we'll be deploying. So we can see we're deploying it into a CPSM CICSplex as a MAS, with the option of either unmanaged as well. We can define the high-level qualifiers of our CICS data sets. We can configure DFH-RPL. We can configure SIP parameters, etc. So this is how the systems programmer will ensure that the CICS regions that are provisioned will comply with the site standards. So we can include the proper security configuration as well, for example. Now, another aspect of the provisioning toolkit, which we're going to use in this demo, there are other ways of deploying applications into CICS, and some of you may have invested in DevOps pipelines, which perhaps use tools like Urban Code Deploy and Jenkins, etc. But again, just to keep the demo simple, we're also going to use the provisioning toolkit to provision the application. So here we see the CSD definitions which will be used, and on the left some of the application binaries which will be deployed to a load library. So this, using the provisioning toolkit, is essentially defined in an application image which we can make available through OpenShift. So at this point, I'm going to drop out of the presentation and start the demo, but I'll just pause for a second and make sure there are no questions. Okay, so let's actually start. Let's start actually in the cloud native developer persona. Let's log into OpenShift. And just to give you a flavour of the cloud native developer experience, here is the developer catalog I mentioned earlier. And you can see this comes pre-configured with a kind of default set of deployable containerized configurations. So there's different middleware and databases and runtimes I can choose from here. So one of the things I can do is import my code from Git and actually deploy it within OpenShift. So I mentioned that we have a web app written for Node.js available. That this is a web app which was created by our team in Hursley to showcase the Node.js support in CICS. But as I said, in this example, we're going to deploy it into OpenShift. So just by copying and paste my repository URL, and I need a context directory to ensure I pick up the source code from the right folder. I think I'm good to go. Now OpenShift hasn't detected automatically the builder image I need, but this is a Node.js application. And it will use the inbuilt Node support for Node.js in OpenShift and to create a deployment. And one of the extra things I can ask for is create a route to my application so I can actually access it directly. So let me click create on that. And here we'll see my application being built and deployed. And we have a visual representation of the application being deployed here. The light blue color actually means it is still in the process of being built. And when that build is finished, that light blue will turn to dark blue. So let's just give this a few seconds and hopefully it won't take too long. And there we go. So in just literally less than a minute, I've taken my application source code from GitHub and have deployed it to a Node.js runtime. I didn't have to install anything myself. It's all available on the cloud platform. And I now am able to access and test that application. Before we do that, let me just have a look at the log of that build, and it will help us understand a little bit about what's happening within the application. And down the bottom here, we can see that we've got a message that tells us that this web app will use API requests that will call CICS using this URI here. That's example.org and port 3001. That is the default URI and port which the application will use if it isn't configured to actually access an actual CICS region. So we know that API will fail, that there is no CICS running at example.org. But at this point, we don't need the CICS region just to test the web app. We will need the CICS region eventually to fully test the app. So let me go back to my topology, and using this little decoration here, I can actually open the URL to the application that I've deployed. And so here we see the web app front end to the CICS catalog manager. And you'll see if I try to access the full catalog, the no surprise, I don't get anything returned. There's no items returned because I'm not actually connected to the back-end CICS application, so there's no data to display. And if I return to my deployment and have another look at the logs, we should see, as we'd expect, we can see the APIs that were issued, and we can see that they were sent to example.org, and as we know, we will not expect it to get any response back from example.org. So far so good. We've deployed our front-end application and tested it. Now we just need a CICS region to test the back end. And being a cloud native developer, the most natural thing in the world for me to do now is go back to my developer catalog and find the CICS region to deploy. And no surprise, there's nothing there. So we're going to spend the next part of the demo to make sure that we do have CICS available in the developer catalog. So to do that, we need to switch persona back to systems programmer. So let me switch to ZOSMF and sign in. So as I say, this is capability that's been around for 5+ years on ZOS. Up till now, it's only been available as a kind of standalone self-service function on ZOS. But the good news is we can reuse this function in order to integrate with the Cloud Broker and OpenShift. So if we look at the cloud provisioning plugin and just have a little look first at what's already been configured, you can see we have a domain called Cloud Demo. So that Cloud Demo represents a subset of resources within the Sysplex. And within that domain, we have a tenant. And that tenant, we've called it Cloud Dev 1. That tenant represents the cloud development team for which we're going to enable self-service provisioning. If we just look briefly at the user IDs, let me go back for a second. We can see that our domain has a number of administrators and approvers, and we have something called domain administrators. What I've created here is a functional ID called Cloud ADM. And that we'll see later on how Cloud ADM is used from OpenShift in order to publish our templates. But we can also assign user IDs or groups to network administrators, workload administrators, etc. Because when it comes to provisioning middleware, we don't just need to consider CICS, we need to consider things like TCP/IP ports, VTAM APL IDs, etc., workload management definitions, and different teams might need to be involved in the provisioning process.
Hi, Steve. It's Rob. Just to let you know, it's 10:59.
Okay.
We're going to stop at 11 for a minute's silence.
Okay. I'll make one more point before I stop then, and that is just like we had the Cloud ADM functional user ID as a domain administrator, we also have the Cloud Dev functional ID to represent the tenants. So just remember those two functional IDs. We're going to use them when we configure the templates within OpenShift. Okay, I'll stop for a minute.
Thanks. Just a minute's silence, everyone, for Remembrance Day. Thank you, Steve. You can carry on now.
Okay, so we've looked briefly at the domain and the tenant. So it's time to look at the templates. So this is the software services function within cloud provisioning and management. And we can see I already have a number of templates created and available. We've got some for CICS, some for DB2, IMS, ZOS Connect. I've even created one for VSAM, which, as I said, I'm not going to use as part of this demo, but just be aware. Templates essentially build on ZOSMF workflows. ZOSMF workloads can be JCL, they can be console commands, they can be rexexecs, etc. You can build workflows to basically do whatever you want, essentially, on ZOS. And then by grouping them together in a template, you can have an entity which enables you to provision a resource. So we're going to use one of the CICS templates today, but I did mention composite templates, so just be aware, not many applications just need a CICS region and nothing else to run. So it is possible to create composite templates to connect CICS to DB2, to MQ, or to ZOS Connect, or indeed to have multiple CICS regions deployed together. So here's something I prepared earlier, which is a template called GSE CICS, and you can see it's in the draft approved state. The first thing I need to do is assign this template to a tenant. So you remember Cloud Dev 01 is the tenant we've created to represent the cloud development team. And I need to give my CICS instances a prefix. I'm going to use the SNA Apple ID, which is going to be dynamically allocated for me as the prefix to name my CICS regions. And here's one of the key things I need to configure, the maximum number of software service instances for this tenant. So this is where the systems programmer can place a realistic limit on the number of CICS regions that each development team is allowed to provision concurrently. Additionally, I can actually put a limit per user, so optionally I can put that as well. And I'm going to allow members of the tenant to access and run the actions themselves. So essentially, this is how I enable self-service provisioning. I'm not going to do it for them. I'm going to allow them to provision their own regions. So let me just click OK in that. So this in turn is going to create what's called a resource pool. And this being a CICS region, I'm going to have some network resources to configure. Obviously, I need an Apple ID, but if you recall our demo, I'm also going to need an HTTP port in order for this region to communicate with the web front end. So ZOSMF has a network configuration assistant. So we've kind of switched personas again. We're really in a network systems programmer persona now. And the network sysprog is going to ensure that the regions that are provisioned use the correct SNA Apple IDs and use the correct pool of TCP/IP ports. So we can see down the bottom we've got our resource pool which has been created for us, but it's currently in an incomplete state. Just briefly, something we've done earlier is prepare an SNA Apple ID range. This is called CICZC, and that actually maps to a real VTAM model definition which exists in VTAM list. So essentially, ComServer has its own REST APIs, which Cloud Provisioning Management is going to use to allocate SNA Apple IDs to each CICS region which is provisioned. And likewise, we have a pool of TCP IP ports in the range 322.0.0 through to 322.99. And again, TCP IP will ensure that that's a range which is not allocated already to other resources on the system. So we have everything we need. What we need to do is modify a resource pool to ensure it has an SNA Apple ID range and a pool of ports to choose from to allocate CICS regions. I can then say my resource pool is complete. Optionally, I can add extra limits here, but we already know we've set limits on the number of CICS regions that can be provisioned, so that should be sufficient. And we can now see that our resource pool has been marked complete. So we now have a template which is now associated with the right tenant. Now what I'd normally do next is do a test run of that template to ensure that it actually provisions the CICS region in the manner that I expect. However, to save time, I'm not going to do that. I'm going to take a chance and I'm just going to publish this tenant. Sorry, this template. You can see I'm getting a warning that I haven't actually done a test run, but that's deliberate. So now it's published. So just before we move on, we can see that we now have 1, 2, 3, 4. We actually have 5 templates in a published state. And what we'll see now is when we switch to using Cloud Broker, that when Cloud Broker connects to the domain that we specify, it will make all of the published templates available for publishing within OpenShift. It will ignore anything that is not in a published state, so we should only see 5 templates available and not some of these others which are in a draft approved state. So it's time to switch to OpenShift. Again, I'm still in the systems programmer persona, so let me log out of the developer persona and use different credentials, admin01, to sign back into OpenShift. And I'm going to switch projects. I don't want the development project. I want a project that I've created earlier called ZOSCB, which is to represent Cloud Broker. So you can see here I've already configured Cloud Broker within OpenShift, and again it's represented here as 5 deployable entities which make up the Cloud Broker application itself. Unlike an application, I can actually use the URI decoration to open up the admin dashboard for Cloud Broker. So I'm still using my systems programmer credentials here, just the credentials that have been allocated to me within OpenShift. And the first thing I need to do is configure an endpoint. I need to connect my broker to a domain within ZOSMF. So let me just copy my URI from ZOSMF. There. I also need the right port, which I've already forgotten. 60443. The name of the domain. Now this is important. This is the name of the domain within ZOSMF, which I'm connecting my cloud broker to, and the domain I want to connect is cloud demo, and I'll also make that the reference name. So I'm going to test and save that endpoint, and all being well, it will connect. So a key thing here is obviously that Cloud Broker needs to be able to connect to ZOSMF over the network. So we're clearly talking about a private cloud environment here. Linux on Z is a deployment option for OpenShift. If you're connecting your ZOS assets to OpenShift, it would make Linux on Z a good deployment option for OpenShift. But otherwise, as long as both Cloud Broker and ZOS are behind the firewall for your private cloud, you can connect them together. So the next thing I need to do is provide some credentials for the domain administrator. So if you remember from earlier, I've created a couple of functional IDs, and one of them was Cloud ADM. So Cloud ADM is the credentials I'm going to use to administer the publishing of templates from ZOSMF into OpenShift. So let me just log in, and again I've got some success, thankfully. And having made that connection, you can now see that the list of published templates, which was in ZOSMF, is now available as an option to publish in the OpenShift catalog. And the one we want to publish is the CICS one. So I can do, if I want, I can actually change some names here. I'll just call it CICS. And one of the things I can do is provide a documentation URL, which developers might find useful. So let me take the URL of the CICS Knowledge Center and substitute that in here, so that developers know where to go to get more documentation. Update that. And finally, I need to provide the tenant credentials. So again, if you remember, the functional ID I've assigned to this tenant is called Cloud Dev. So let me fill that in, and all being well, we now have a properly configured connection from ZOS Cloud Broker to ZOSMF to the cloud demo domain. Now, you'll see here that this catalog was last refreshed 4 minutes ago. So I'm going to ask you to ignore what I'm going to do for the next minute while I speed up this process. That catalog refreshes every 10 minutes. So rather than wait 6 minutes for our template to be published, I'm going to try and speed things up if I can remember what to do. So ignore all this, please. just taking a minute to populate. Okay, and we're back. So if I return to my catalogue, I'm hoping now it actually has refreshed. Yes, so we have a refresh, and we can see that there is now a service entry available. So if I return to OpenShift and have a look at the service catalogue, and now actually search for CICS, with a bit of luck, we'll now see that CICS is now available as an entity which can be provisioned natively from OpenShift. So, job done from a systems programming point of view. So finally, we'll return to the Cloud Native Developer persona. So let me log out of admin and re-log in with my developer credentials. The first thing you see, because I'm using the same browser, I've defaulted to using the same ZOS Cloud Broker project, which the systems programmer was using. And reassuringly, we can see that the developer has no access whatsoever to the Cloud Broker project. So the developer has no access to configure which templates and which domains are available through OpenShift. What they do have access to do is provision resources. So let's return to the catalogue and find our newly published CICS template. And by creating the Create Service Instance button, what we will do, we can call this whatever we want. Let's call it My CICS. We can provision a CICS region. Now, here is where I mentioned earlier which we're using the ZOS Provisioning Toolkit in order to provision the application itself. So what we've included here is a parameter which can point to my application tar file. This is a tar file which includes information to deploy the application binaries, the load modules, and the CICS CSD definitions. So as part of my CICS provisioning, I'm also going to deploy that application. Okay, click Create, and we can see we're currently in a status of not ready. So what we'll do while we're waiting is switch back to the systems programmer perspective and actually have a look in ZOSMF as to what's actually happening. And we can see that there is a CICS region in the process of being provisioned, thankfully. And if we want to, we can actually have a look at the workflow and see how that provisioning process is progressing. So we can see we're already 95% complete. This is a generic template which supports connecting CICS to MQ and DB2, etc., which are not applicable to us. If we can scroll down, we can see that we've had region datasets created. We have SIP parameters defined. We've obtained the host name for the ZOS image. We're currently in the process of creating a CSD. Let me refresh that. So we've now completed the creation of the CSD, and if we actually want to go and look at any of these steps, we can drill down and look at the CSD definitions that have been created, and you'll see that this workflow step actually is represented by a job which has been submitted, and we can have a look at the output of that job. So if anything was to go wrong, the systems programmer can easily find out what's wrong with this template and make any changes that are necessary. Let me just go down to the bottom just to make sure that the application whose resources we saw earlier has actually been defined. So we have a transaction, a couple of VSAM file definitions, and a pipeline. So a pipeline which will enable us to pick up our JSON Web Services. So all that looks good. So let's return to the developer. Yeah, here we are, to the developer persona. Nearly finished. So we can see we now have a status of ready, and actually we have an instance dashboard available within the broker, which the developers can use using their OpenShift credentials to actually see the status of their CICS regions or databases or whatever it is. So key point now is that the template we've used includes a number of environment variables which can be made available to the developer. So, for example, we know what the Apple ID of the region is, we've provisioned. But more relevant to what we're doing, we know the name of the number of the HTTP port, and we know the host name. And so we have all the information we need within our web application to connect to the CICS backend. We need the host name and we need the HTTP port. And as it says here, these variables can be consumed through Kubernetes secrets. So without getting down into weeds as to what a Kubernetes secret is, we're actually going to create that via this service binding. So what I've created is a Kubernetes secret which contains those environment variables. So it contains the host name and the port where my CICS region resides. So that's now been created. And as you can see, I can now add this secret to my workload. So the workload I want to choose is the same workload in which I've already provisioned in my web app. So let me save that, and you can see it's now automatically rebuilding the web app which I deployed earlier. You may have briefly noticed it turned from dark blue to light blue. That tells me it was in the process of being rebuilt. In fact, if I now return to my web app and look at the logs, hopefully I will see that those environment variables have indeed been consumed and my application has been rebuilt, and it now will call CICS with the correct host name and the correct port. So hopefully now, without having to make any changes, just by provisioning my CICS region and application, I'm now able to retest that web app, and it should in fact connect to a real CICS region this time. So let me return and re-invoke that web app. And with a bit of luck, already we can see a bit of a difference. So let's have a look at the full catalogue. And this looks quite reassuring. I'm actually seeing some items, pens galore, printers, and my web app is working as designed. It's allowing me to actually buy these items. So all that looks good, but just to double check, let's go back to my logs and be reassured that my application is making the correct API requests, and we can actually see the response from CICS. So this is the CICS application reading the VSAM files and returning the information that I've requested. So all that went very well. All that remains is for me to deprovision the CICS region. So let me just quickly show in the few minutes we've got left how to do that. Again, I'm using the OpenShift service catalog to do this, and where we can see my CICS. I must be careful to delete the Kubernetes secrets, the service binding first. So having deleted that, I can now delete my CICS region. And again, likewise, while that progresses, we can switch back to ZOSMF and actually have a look at what's happening. And hopefully we'll see that the CICS region is now deprovisioning is in process. And again, if we wanted to, we could look at those workflows and ensure everything is proceeding as planned. Okay, so that's the end of the demo. Let me just quickly make some concluding remarks. Is there any questions, Rob, before I finish?
No questions in the chat, Steve.
Okay. So just a quick glossary of the different technologies we saw in the demo. We saw Red Hat OpenShift Container Platform, which is certainly IBM's enterprise Kubernetes platform of choice. Within Cloud Broker, we also support Pivotal Cloud Foundry. So if your organization is using Pivotal Cloud Foundry, be assured Cloud Broker can also support that platform. We talked about Broker, we talked about ZOSMF, we talked about Cloud Provisioning Management, which is the plugin to ZOSMF, which enabled us to create the domains, tenants, and templates. We used the Zos Provisioning Toolkit for two things. We used the template for provisioning CICS, and we also used it to deploy the CICS application as an image. And we saw the CICS Catalog Manager, which is provided by CICS, and a Node.js front end for that, which is available on GitHub. Just briefly, what do we have to look forward to? Earlier this year, IBM made a statement of direction that intends to deliver containers and Kubernetes orchestration on ZOS. So that will build further on what we've seen today, in that, as well as native provisioning of the web front end in Node.js within OpenShift, we can start to see native Kubernetes orchestration for CICS regions and databases within OpenShift as well. So all that's to look forward to. And we've got a new release of Cloud Broker, which will become available next month, which supports the latest release of OpenShift. And what we'll start to see is, in addition to support for ZOSMF, we'll start to see support for Ansible playbooks on ZOS as an alternative automation method for provisioning resources on ZOS. So with that, I'll just leave you with this slide just to summarize the middleware which Cloud Broker supports on ZOS. So using Cloud Broker, you can enable self-service provisioning of not just CICS, but DB2, IMS, MQ, WebSphere Liberty, and ZOS Connect. So thank you for your time. I'll hand back to you, Rob.
Thank you very much, Steve. There's the QR code for feedback, everyone. Very interesting to me, Steve. We've seen CICS and Kubernetes, and we're now seeing how that works with OpenShift. So very interesting. And I think for new work, for like if you were putting in a Java application, I can see how it would fit very nicely and be less complicated than perhaps slicing and dicing some of our monoliths up to fit into this template infrastructure. So really good. We're back on again with Jenny doing CICS performance at 12 and Ezra doing CICS internals at 1:30. So if you're interested in either of those, I'll see you then, folks. Thanks for your time, and I'll close the session now. Cheers.